So now we have introduced the data types and data structures in Python. A particularly useful data structure is the data frame provided through the pandas library. And now we finally have the most important tools to start analyzing data. And we start by doing some exploratory data analysis. So in order to do some exploratory data analysis, which is to find out what's happening in your data, one important thing is to make use of a technique called data aggregation. Usually for any data set we have, there are many records in that data set. It's meaningless to look at a individual row because that doesn't give you the whole picture. It's important to be able to do some overview of the data from an aggregate level. In that respect, it becomes important to look at the summary statistics such as mean, median, standard deviation, the whole bunch of stuff we are already familiar with from statistical theory. So let's switch to our Jupyter Notebook. And then we're going to see how we can do data aggregation and calculating summary statistics on pandas data frame. And this time we're going to look at a data frame that we have used before. Remember, this is a data frame about a total number of 6 stores in different cities. Every row is the record of a store. Every row tells us the manager of that store, the city where the store is located, how many employees we have, and how much revenue is generated for a certain given time period for that corresponding store. This basically constructs the data frame from a dictionary. It's something we have done before. And the data frame now has a name called stores after we constructed it and assign it to this variable stores. We can take a look at the head of this data frame. Right? It's just the one we wanted to create on the previous screen. A very first step to have some high-level idea about what's happening in that data frame will be to use the info function. It's actually stores as the name of the data frame. Now we can see it gives us some summary. The information include that it tells us the name of every column. Every column, it helps us count how many records that are not missing values are included in each column, as well as the type of data associated with the columns. Employees, revenues, those are numerical columns telling us the number of employees and the number as the revenue volume for every store. For manager and city, those are string valued columns. So it tells us that the type is object, which include string or textual values. Now, another useful method for any data frame is the describe function. We can do stores.describe and see what it tells us. As we can see, even though we have managers, cities, employees, and revenue, the 4 columns, if we use describe, the results shown here only include employees and revenue. That's because only those two columns are numerical valued. This describe function returns us some summary statistics of the numerical columns. Non-numerical columns are dropped automatically. As we can see, for the employee column, it tells us that the count is 6, meaning that there are 6 records that are not missing values, right? Mean value is 21, so on average there are 21 employees across the different stores. Some have more, some have less. And standard deviation, minimum value, maximum value, also the quartiles. 25 quartile, sometimes we call that 25 percentile, sometimes we call that the first quartile, and 50% percentile, that's the medium, and 75 percentile, that's the third quartile. Right? So basically, we know, for example, from the median value that half of the stores have a count of employee number below 21 people. And also half of the stores will have a revenue below 27. So that's about the overview of the whole data set by using info and describe. Often we are interested in every single variable, but by variable usually we mean the columns of the data set. We have mean, summation, maximum, minimum, so on and so forth. For example, we can look at a particular column of the data frame. So stores is the name of data frame, and let's use square brackets to select a column. Let's select employees. Then if we are interested in the particular statistics of that column, let's say the mean value, then we will use dot mean and followed by parentheses because that's a function. So that's when we know that across the different stores, the average number of employees is 21, right? If we want to do, let's say medium, just replace mean by medium. In this case, it's also 21. We can do sum for summation. That will help you add up the numbers of employees for all the stores. In other words, you get a number, 126, as the total number of employees from all of those stores. We can also apply a statistics function on the whole data frame. And to do that, it's even easier. We can just do stores dot say mean. And if we run this command, we may get an error. So why is that? And to understand why there's an error, well, we can just simply quickly return to the original data frame. Now we can see that we want to do mean value calculation on the data frame. What Python or pandas will do for us is that it will look at the separate columns individually and apply the mean function to all those columns, which is somewhat problematic for the first two columns because those first two columns are not numerical, right? Manager name and city of the store, well, we cannot really do anything like mean value or median value for those columns. So quickly returning to our code, we need to make one adjustment. What we need to do is to specify that numeric only equal to true. Right? And that will ask pandas to focus only on the numerical columns, employees and revenues, and then I want to calculate the mean value of all stores regarding the employee number and also the mean revenue across the different stores. You can do medium, you can do summation, just replace the mean function with median or sum function. For example, we can try one. We can do stores dot, let's say, std, and that will, std, and then we also need to specify numeric only equal to true. Again, we focus on employees and revenues, those two numerical columns, and we get a standard deviation of the two columns, right? So basically, employees have standard deviation of 3.74 that measures from store to store how the values of the number of employees actually varies across stores to stores, right? Give us some information about how the different stores differ in terms of the numbers of employees they have in their stores. Also, we can do percentiles, and this is doable through a function called quantile. Right? Quantile, percentile, those are similar terms. Let's take a look at how we can do this. This time, let's again focus on the employee column. So we're going to do stores, selecting the column of employees. I want to find out 50% of the stores will have no more than a certain number of employees. So basically, this means that we have a total of here only 6 stores, right? So 6 times 56%, that's just roughly about 3 stores. So the question is really, we'll find out a certain value on the number of employees so that roughly 3 stores will have no more than this number of employees. Right? Let's try to do the calculation first. We're going to do stores employee to select that column, and then do quantile. Right? And inside the quantile, I'm going to provide the percentage converted into a decimal number, 0.56. And then the answer is 21.6. I mean that 56% of the stores, which is roughly 3 stores, will have no more than 21.6 employees. Okay, this is a small data set, so it's not so intuitive, but imagine that you have a large data set, have thousands of stores, and things will become making more sense. Now we can also calculate multiple quantiles or percentiles at the same time. Let's say stores dot, square brackets, let's select revenue this time, dot quantile. Then I'm going to provide a list. In the list, we'll include the percentages. Right? So the first one, let's say 0.3. The second one, let's say 0.47. And third value, third percentile will be, let's say 0.87. And then run the cell. It will show us the 3 quantiles, right? So 30 percentile, and that's going to be 23.5, and 47 percentile is equal to 26.7, and 87 percentile 31.4, right? For example, look at the last row. It means that 87% of the stores will have no more than a total revenue of 31.4, right? So that's the meaning of the percentiles. So basically, we're trying to find the percentage of stores that has a certain attribute below a given value.